Hello, in this lesson, can we learn on how to solve simultaneous equations using the elimination method? So, for example, let's say you have a set of equations like this. The first thing you note here is we have two unknowns, x and y. So, to solve these equations using the elimination method, this is how we go about it. Let me first copy the equations in my board. Let me call this equation 1 and this equation 2. So our elimination works is, I want to force one of these unknowns to look like the other. So in this case, for example, when I have x in the second equation, I can force it to be 4x so that it can look like the 4x in the first equation. Or I can force y, this 2y, to be 3y, or this 3y to be 2y so that they look the same. But you see, in this case, 2y and 3y is very hard to force them to look like each other. So the easiest one here is to force x to look like 4x. And how do I go about that? What I need to do is I look for a number which, when I multiply it with this equation, it will make this x be 4x. In this case, I can just multiply the second equation with 4, because if I take 4, then multiply this x with that 4, it will be 4x. But because I've multiplied this x with 4, then I'll have to multiply all the other values in this equation with that 4. So I can do it like this. 4 into x plus 3y is equals to 11, but also multiplied by 4. So if I multiply here with 4, I should also do that here. I should also do that here, so that the whole equation is multiplied by 4. So now it becomes 4x plus 12y, I just open the brackets, is equals to 44, like that. So now the second equation changes to this. But you see, the first equation was 4x minus 2y is equals to 16. And now the second equation has become 4x plus 12y is equals to 44, like that. So now you see this 4 and this 4 are the same. Of course, this 4x and this 4x. So the next step is to, if these two are positive, I need to subtract them so that I eliminate them totally. Or if they are negative, I need to add them so that I can eliminate them totally. But in our case, because it is simple, let's just subtract them. So here, I'll do like this. And then I put a subtraction here, a subtraction sign here. So what I mean is, I'll take this 4x minus 4x is 0. Then again subtract this 2x from 12, this 2y from 12y. So in this case, it will be negative 2y minus 12y, which will become minus 14y, is equals 16 minus 44, which will become negative 28. So now it becomes minus 14y is equals to negative 28. Then y becomes negative 28 divided by negative 14, which is 2. Because this negative cancels with this, then 28 divided by 14 is 2. So now that I know the value of y is 2, I can get the value of x. I can pick any of the equations. For example, I can pick equation 2 and say x plus 3y, but I already know y is 2, is equals to 11. So x is the same as 3 multiplied by 2 is 6, then 11 minus 6, because this 6, when I move it to the other side, it becomes negative. So x becomes 5. So the solution for this equation is x is equals to uh, 5 and y is equals to 2. So that's how elimination works. Can we do another example? Let us say you have a pair of equations like this. Let me first copy them in my board. Then we call this equation 1 and then this one equation 2. So the first thing we need to do here is to arrange all the unknowns to be in the same column like this. So to start with the first one, which is 2y, like I say, it's 2y, then take this x on this other side, it becomes minus 6x is equals to 4. And just retain that 4 there. Now this is still our equation 1. Then this x plus y is equals to 10. I can change it to this. Y plus x is equals to 10. I didn't do anything significant here. I just interchanged the values because both of them are positive. I just put the y here, then the x here, and retain the 10 here. So now this is equation 2, of course, and our new equations become 2y minus 6x is equals to 4. Then y plus x is equals to 10, like that. So now we have all the unknowns in the same column like this. So what we need to do next is to find a number which will multiply in one of the equations to force one of the unknowns look like the other in the other equation. So in this case, if you see, for example, this y, I can just force this y to be 2y. And to do so, I need to come to this equation 2 and then multiply every place with 2 so that this y can be 2y. So I multiply this y by 2, it becomes 2y plus then this x again by 2 because I multiplied here by 2. What I need here, I should do here and I should also do here. So again, 2x is equals to 10 multiplied by 2, which is 20. So this is still our equation 2. So now our new equations become 2y minus 6x is equals to 4. Then again 2y plus 2x is equals to 20, like that. But you see now these 2y and 2y are the same, so I can just subtract them like this, which means 2y minus 2y, which is 0. Then minus 6x minus 2x, because this 2x here was positive. When we multiply positive by negative, it becomes negative. So it now becomes minus 6x minus 2x, which is minus 8x, like that. Is equals to 4 minus 20, which is negative 16, like that. So it becomes negative 8x is equals to negative 16, like that. So to get x, I need to divide each side with negative 8. So x is equals to negative 16 divided by negative 8, which is 2. And now that I know the value of x, I can get the value of y from any of these equations. I can just pick equation 2 and say x plus y is equals to 10, but I already know the value of x, which is 2. So 2 plus y is equals to 10. So y is equals to 10 minus 2, which is 8. Can we do the last example? So I will do this question 1, then you will solve question 2, 3, 4, and 5 for practice purposes. So let's go to this one and then I copy it in my board here. So the first thing as usual is to arrange all these unknowns to be in the same column. And as you can see, the first equation is 3y is equals to 9x plus 6. So I can write it like this. 3y. I take 9x to the other side, which becomes minus 9x is equals to 6. This becomes our equation 1 again. Then this one, x plus y is 14. I can interchange y to be there. Then plus x is equals to 14. And this becomes our equation 2 again. So from there, since I have this y and this y in the same column and 9x and 9x in the same column, I can now force one of these unknowns to look like the other in the other equation. For example, here, since I have y and here I have 3y, I can force this y to be 3y. And to do so, I need to take 3, multiply 3 across this equation. So it will be 3 multiplied by y, which is 3y, plus 3 multiplied by x, which is 3x, is equals to 14 multiplied, which is 42. Then from there, we can arrange them again like this to be, our first equation was 3y minus 9x is equals to 6. Then we have the new one, which is 3y plus 3x is equals to 42, like that. Then, since after all, now this is 3y and this is 3y, I can subtract them like this. And then I take 3y minus 3y, which is 0. Then minus 9x minus positive 3x, it will be 9x, negative 9x minus 3x, which is minus 12x, is equals to 6 minus 42, which is negative 36, and therefore minus 12x is equals to negative 36, and then x is equals to negative 36 divided by negative 12, which is the same as positive 3. So that's the value of x. But we also want to know the value of y. And the value of y, you can do it from any of these equations. So I can just pick this one. I say x plus y is equals to 14, like that. But I already know the value of x is 3. So 3 plus y is equals to 14, like that. So y is equals to 14 minus 3, which is 11. So the solution for this is x is equals to 3 and y is equals to 11, like that. So thank you for now. Let's meet in the next lesson. You can try to solve the remaining questions so that you see if you understand the concept. If you don't, you can leave a comment on the comment section and ask me any question. I'll be available to reply. Thank you.